Hello everybody, how's it going? My name is Jack Toll, and today I wanted to make a video going over my local setup for how I train models in VSCode using a Google Cloud Compute VM instance. So essentially, Lab recently moved from a different provider to Google Cloud to do the majority of its model training. And this meant that I needed to set up some compute instances to get model training to work, and I found it a bit tedious at first. And also a lot of I ran into a lot of sort of weird issues that I couldn't immediately find the answer to. And I finally got it working, and I just wanted to make a video sort of sharing from the beginning to the end. So if anybody else wants to get started with Google Cloud as their GPU provider, they can sort of follow this guide for it. So currently I'm on the Google Cloud just main console, and you'll see under the quick access here, we have Compute Engine as one of the tabs here. We're just going to initially click on Compute Engine. And there's going to be nothing here at the moment because we haven't created any VM instances. So we're just going to click Create Instance, and we're going to get to this page here. So this is where we can configure our entire instance, essentially. So this includes allocating CPU, RAM, persistent storage, GPUs, networking stuff, the whole lot. So just for the sake of this tutorial, I'm going to just name this test instance. I don't really care about where it's located right now. This can all stay at its default. The one thing I am going to do, because I'm going to be using this instance for deep learning, is I'm going to click on this GPUs tab here. And then GPU type, we can select which ones we want. Now, obviously, some of these are going to be way more expensive than others. For this tutorial, I'm just going to be using an NVIDIA T4. And just here you can select the number of them. I'm just going to select one for right now. You can see on the right hand side here, we have sort of the cost breakdown. So for every hour that the instance is running, we have to pay essentially 28 cents. And that means that if the instance was running 24/7 for a month, that would equal about $204. This is sort of the base price just for the GPU allocation. Everything else is going to sort of add on top of that, whether you want static IPs over ephemeral IPs, whether you want more persistent storage than the default, all of that will sort of add to this price here. Anyway, that's essentially all we have to do setup wise. The only other thing that we have to do is when we scroll down and we go to boot disk, we see this little thing saying the selected image requires you to install an NVIDIA CUDA stack manually. To skip the manual setup, click switch image below to use a GPU optimized Debian OS image with CUDA support and no additional cost. So we're actually going to do that because that saves a lot of time. The default one I've found works really well. It automatically goes on deep learning VM with CUDA 11.8. And here, this is where we can select we can increase our persistent storage if we want. So here I can just change it to 100 gigabytes. As soon as we do that, I can essentially just hit create, and then it starts creating the instance. While we wait for this to start, I'll quickly go over what the next steps will be. So as soon as this instance begins, we're going to see a little button just saying connect with SSH. Now we're going to initially do that just in the Google Cloud console for the initial setup, and then we'll take a few extra steps in order to get it working locally in our terminal and also eventually in our Visual Studio Code. So we'll just wait for this to complete. Perfect. So the instance has finished starting up. So here is the SSH connect button. Now, when we click this, it's going to open up a new window, SSH in browser. Now, essentially, the first time that we run the instance, it needs to actually do the installation of the NVIDIA drivers and sort of the CUDA setup. So as soon as it connects, it's going to ask us to select Y or select yes in order to complete the installation. Here we go. So we can see that the SSH in browser has started up. And here we get a little message saying the VM requires NVIDIA drivers to function correctly. Would you like to install the NVIDIA driver? To which we're going to say, yes, we do. So I'll just let this run. Okay, perfect. Now that the installation has finished, I like to just run 2 initial commands just to sort of confirm this. So the first one, just to make sure that the system is recognizing the CUDA compatible GPUs, I'm just going to write NVIDIA-SMI into here. And here we can see a bit of a table showing our Tesla T4 and just sort of some details about it. Something else I like to run now that the drivers, the NVIDIA drivers and CUDA has presumably been installed for us automatically, is going to be NVCC and then space, and then we do 2 dashes, and then we just write version in here. Then we hit enter, and then it prints out just some of the version information about the CUDA version that we've got installed. So we can see we have CUDA version 11.8 installed here, which is exactly what we expect because that's what we selected with the pre-built sort of machine. Okay, so now that we actually have this working here and we can connect to it, the next step is to connect to it from our local machine. So this is going to require a few extra steps, but it should be relatively easy. So the first thing that you're going to want to do is head to your C drive, head to the users folder, head to your specific user. In this case, for me, it's Jack. And then there's going to, maybe you already have a folder in your user called .ssh. And if you don't, then you're going to have to create one. So I do have one, but I deleted all of the contents inside of it just for the purpose of this demonstration. So we get to see sort of the start to finish process here. So in order to add the right files that we need to essentially create a public key that we can that will get stored here under the Google Compute Engine name. And then we're going to take that public key and we're going to put this inside of our instance in the Google Cloud Console. And then that's going to sort of allow us to do authentication and verification that we are who we say we are when we're connecting, which is what's going to allow us to connect so easily. So what we're going to do is just open up our terminal and we're going to write this command here. So this is just the SSH keygen, which we're generating a public key. And where are we going to be generating it to? Users jack.ssh, and we're going to be writing it to a file called Google Compute Engine, and that's where it's going to be stored. So if I just write this, it says generating public private RSA key pair, enter a passphrase, empty for no passphrase. So we're just going to leave it empty. And here we go. So it automatically creates it here. And if we look here, we can see that we have these 2 files that have been created in this .ssh folder. Now, the next thing that we're going to want to do is copy all of the contents of this. So I just have this other command here, which is type and then the and then the directory. And then when I hit enter, this will print out the entire public SSH key. So what I'm going to do is copy the entire key, including the end where it says jack at jackpc, starting at ssh-rsa. I'm going to go back to test instance in the Google Cloud Console. I'm going to hit edit. I'm going to scroll down until I find the SSH public keys. I'm going to add an item. I'm going to fully paste mine in there. And then I'm going to hit save. Right after this saves, the public key, which is sort of associated with this PC that I'm currently on, is going to be inside of the Google Cloud console. So it's going to have a bit of an idea. When I try connecting from it, it's going to read this folder, and then it's going to sort of confirm to make sure that I am who I say I am. So the next steps is to locate the username for the SSH public key, which you can see if I just find SSH keys. You can see that the user here is Jack, and the IP address, I have ephemeral IP addresses at the moment, which means that every time the instance stops and starts, the external IP address changes. However, if you do pay for the premium static IP address, then it's just going to be the same every time. But that's just something to keep in mind, that if I were to stop this and start it, then this external IP address will be different. The reason that that's important is because now we're going to connect to it, and we're going to need the username, which I just got a second ago from the SSH public key area inside the instance. And also we need this external IP address here. So what I'm going to write is SSH-I, and then I'm going to give the directory for the path for where my public key is stored. Then I'm going to say my username, which is Jack. I'm going to do an @ sign, and then I'm going to copy the external IP address and paste it in here. It's first going to ask me if I want to create a fingerprint. I'll say yes, permanently added, and here we are. I am inside my instance on my machine. NVIDIA SMI will yield the same result. Now, this is really good, but you have access to sort of a terminal in Google Cloud Console. So sort of connecting to it in a terminal locally is cool, but it's not really the functionality that you're after if you're going to be doing this. If you're trying to get it working locally anyway, a lot of the time that's because you want to do a bit of a remote SSH connection in your IDE or your code editor like VSCode, so you have a bit more of the standard UI experience when you're writing your training scripts and you're moving files around. So the next step is to get it working here. So what we're going to do, it's really simple. We're going to exit out of this terminal. We're going to take this exact same SSH connect line that we just used to connect in the terminal. In VS Code, we're going to go down to this little icon in the far bottom left. We're going to click on Connect to Host Remote SSH. We're going to say Add New SSH Host. We're going to paste in that exact same thing. It's going to ask us to select an SSH configuration file to update. We don't currently have a config in there, but we're just going to select config anyway. Now, when we do that, it's going to create a config file. However, this is really important to note. The config file, by default, and I have no idea why, it doesn't have the path to the Google Compute Engine public key in the correct format. Here we go, not in the correct format, as you can see. It's missing all the slashes, and that, I don't know why, but that's a big issue. So what we need to do is after the colon, we need to add a double slash, after the users, a double slash, after the Jack, a double slash, and after the .ssh, a double slash. Now that we've adjusted this, we can exit out, and now we can hit connect. Now what this is going to do is next connect it. We need to select that we've picked a Linux machine. We can make this full screen now. And now this is going to set up our SSH server that is running on the Google Cloud, but in our Visual Studio Code. So now if I hit Explore, Open Folder, and I click OK, it's going to open up a new tab. I hit Linux again. It does the connection, and now that the format is fixed, it's really easy to connect to it. I trust all the authors, and here we go. We get to see all the files and the folders inside of our instance. So now we can treat this like we do our local machine. We can add a new folder. This can be some sort of training example. Within this folder, we can make a new file. We can name this train.py, and we can just start writing our code without any bells and whistles, and we can copy and paste our code or drag and drop files and folders from our local machine into our Google Cloud GPU VM instance, and it's completely seamless and super easy. There is one thing to note, that is that that currently we don't have PyTorch installed. Now, I did have a few issues installing PyTorch originally, but that was just me being installing sort of the wrong thing, or I was doing it in a bit of a backhanded way. But now that we're doing it sort of from scratch like this, if we just go on install PyTorch, start locally, here we're going to want to select stable, Linux, pip, Python, CUDA 11.8, and then we copy this command. We can go right here, open a new terminal. We can install this for right now. Now in this terminal, we're going to just want to do the copy and paste the command. And since we've specified the correct version of CUDA, we're just going to let this PyTorch installation run so we can make sure that CUDA is sort of available and we can start training deep learning models using the deep learning libraries such as PyTorch and transformers and datasets and all of that good stuff. So we'll just let this run. I'll be back with you in a second. Okay, perfect. Now that everything has installed, we're going to do a little test to see if CUDA is available with PyTorch, just to make sure that everything has installed properly. So you can see that after running the pip3 install for Torch, Torch Audio, Torch Vision, a lot of other things installed as well. That's CUDA related. So we can see like CUDA GPU related stuff, everything that I guess was initially missing, but that is required for CUDA to run with PyTorch, or I guess any other deep learning framework, additionally installed, in addition to Torch, Torch Audio, Torch Vision. So now just to do a test, we'll enter a Python 3 Python instance here in the terminal. We'll import Torch, see if that spits out any errors. No, it didn't. And then we'll run the torch.cuda.is available. And here we get a return of true, which is exactly what we need and what we want. And this is like any other instance, even if it's just your local machine. We can make virtual environments with specific versions of Python in there. We can install Brew if we want, or Homebrew, in order to do package management. So we can create a virtual environment inside of our training example here. We can install all the dependencies that we need for a specific training script. We could even install any specific versions of PyTorch that we want there. But it's good that we have this PyTorch with CUDA working in the base or global environment, because that means that we don't actually have to struggle with any of that stuff in the virtual environment if we don't want to. So that's all for today. I don't have a training script right now that I'm going to run, but rest assured that this works at the moment. And it's a very user-friendly environment right now because it's exactly what you're familiar with. You can drag drop files. It's just Visual Studio Code. And now we can scale it up really easily. So this is only using one NVIDIA T4 graphics card, but you can, and only one of them. But here you can easily adjust your instance to be to change the GPUs to A100s instead of the NVIDIA T4s. Maybe you don't just want one of them, but you want 4 of them working, right? You can do that now, and instead of working in a little tiny terminal inside like a browser window in your Google Cloud, or instead of working in the little Google Cloud GCloud terminal on your computer, now you can do it sort of a bit more natively and a bit more locally, which should make your whole pipeline of training models with good hardware a lot easier. Anyway, thank you so much for watching. I hope you enjoyed. I hope you learned something new about all of this stuff. It is a bit tedious getting all kind of the steps right. I had problems where it wasn't sort of getting my public key properly. I didn't know that I needed to just sort of wipe the folder and then recreate the public key and only put that one in here. But anyway, I got it working eventually. I wanted to share what I learned here with you. I'm also going to be turning this into a simple blog post in case some people just enjoy reading it instead of listening to a whole video and me just talking so much. Anyway, I hope you have a fantastic day or night, and I'll see you next time.